Okay, so this go around, we're going to skip the explore and reason on this one, um, just due to time and constraints that we have. So we're going to skip over this one, so don't worry about that in your workbook. Okay. All right, starting with example number 1. Okay, it says solve a system of linear equations. So again, talked about this previous to this when you guys were doing vocab. A lot of what we're doing in this section, I believe, is something that you did in Algebra 1. So this might be review for you, some of this might be brand new. So please, again, like normal, like always, make sure you're asking questions so I can pick up on the gaps that you might have on this section, okay? The book does it a little bit different, so we'll look at this, but I think I'm going to show you some other ways, which is probably the way that you learned it in Algebra 1, just so we're staying with the same style, okay? So it says, what is the solution of the system of linear equations? Okay, so we have two different equations. These are both written in standard format versus linear, okay, which has the x and the y together, where the other one, where we have y equals mx plus b. Okay, so you could always rewrite these if you wanted to and graph them as y equals mx plus b versus the standard format. Okay, they already graphed the two lines for us. Okay, so and they showed that they did it with substitution. Okay, so with substitution versus elimination, you are plugging in and getting a variable by itself. So on either the first one or the second one, don't write this, okay, first one or the second one, I could have rewritten this and gotten one of the x's by itself. So if I chose to do this one and got the x by itself, then all I'd be doing is moving that 2y to the other side, okay, which would change it from a positive to a negative 2y. Okay, and then shifting, pushing the 3 over, it's not moving to the other side, so it stays the same, okay? So if you do substitution, then that just means now that I rewrote that, x is equal to this, so if x is that, then I can take this part of the equation and plug it into where the x is at, okay, and then solve it. So that's what they showed down here, okay? They got the x's by itself, okay, this is the one that we have right here, okay? I just have the y written first, okay? Solved it, and then you can plug it in, or you can do the other one, the bottom one, it doesn't matter, okay? And so when we do that, then we would move that to the other side. They move both of them to the other side and set them equal to each other, okay? So substitution is one of them. Elimination is the other one. And I actually think elimination is the best on this one, because if you look at it, with elimination, if they're lined up, x's with x's, y's with y's, and the number off to the right, the whole the constant, if you have the same number and one of them's positive, one of them's negative, you can eliminate. So instead of doing substitution, I would do elimination. Okay. So this is the example that I believe I had you do in your vocab. No, I didn't. I had to do a different one. Okay, so we're going to try this one. Okay, so this you are right. Okay, so I have my two equations. I have x plus 2y equals 3, and then I have x minus 2y equals 4. Okay, my x's are lined up, my x's are lined up, my y's are lined up, and my constant is lined up. Okay, so when we use the elimination method versus the substitution method, the numbers are the same, and one of them is a positive and one of them is a negative. Okay, so we are actually already set up for that. Okay. So that means I have a positive 2 and a negative 2. They eliminate each other. They are not. Okay, so now we're just combining what is left. So I have a positive 1x, a positive 1x. So now I have 2x. I have a positive 3 and a positive 4. So now I have 7. Okay, so then to solve for x, all I would do would be divide by 2. Okay, so my x is 7 over 2. Okay, which is what they did right there. Okay. So different methods, substitution versus elimination, is still going to get you the same answer. It's just two different ways to do it. Okay. And then what they showed on the graph, that if you were to actually graph it, what we're looking for is where is the point that they cross each other. Okay. What is the solution to that equation? So as long as they cross each other, the point of intersection is a solution to the equation. Okay. So now that we have the x, okay, we can plug that x value back into either the first equation or the second equation and solve for the y, okay? So they have the answer right here, which is a negative 1/4, but it's really hard to tell in the graph that that's what that is. Okay, so if I chose to plug this one in, my x value, okay, back into, I'm going to plug it into this one, okay? So I would have 7/2, okay, because I'm replacing the x with that, plus 2y equals 3, okay? I don't like working with fractions, so I'm going to multiply the whole thing to get rid of it. You can work with fractions if you want to, but I'm not going to. Okay, I'm going to multiply by the common denominator, which is 2, the only denominator that we have, okay? So on the first one, 2 goes into 2 and just leaves the 7, okay? But here I don't have a denominator, so that means I actually need to distribute my 2 to both of these to rewrite this equation. So 2 times 2 is now going to give me 4y, and then 3 times 2 is going to give me 6. Okay, so to me, this blue equation is easier to simplify than that red equation, okay? So now I'm going to move the 7 to the other side, so when I do that, it's going to become a negative 7. So now I have 4y equals a negative 1, and then divide by 4, so my y is a negative 1/4. Okay, so again, that's what was in the book. Okay, so I just showed you a different route than the route that they have in the book. Hopefully you'll remember that from your Algebra 1. Okay, all right, so now your workbook, we are going to try this. Okay. Okay, so in your workbook, try it number 1. It says solve each system of equations. So notice it doesn't tell you to use substitution, use elimination, or to use graphing, or any of that. So you're just picking the option that stands out to you, okay? If you were to graph it, which I'm not going to take a whole bunch of time because I've already done it, you can do the 0, plugging in 0 here and solve for y, and plug in 0 for y and solve for x, and then graph it. You could do it that way. Or I could rewrite each one of my equations to get the y by itself and graph it that way, okay? So regardless which one, I'm just drawing a small sketch here, okay? We're going to have one of them that's going to go, let me do different color, sorry. One of them is going to go through and look like this, if you were to actually go through the process. And then the other one is going to go through coming down here. So if I graph them, I would know that they cross each other. So they are going to have a solution to the equation versus if they never crossed each other, there is no solution, okay? So we are going to have one answer, okay? I am choosing to use substitution, okay? Because the elimination one, they have to be lined up, x's with x's, y's with y's. They're not lined up. And then also, I don't have any numbers that are the same. So if I look at my x's, I have a 2x and a negative 6. Okay, and then for my y's, I have a 1 and a 5. Okay, so that one doesn't stand out to me to use elimination. So I'm going to use substitution. Okay, so I am going to rewrite this one to get one of my variables by itself. Okay, so if I rewrite that, I can leave the y by itself and move the 2x over to the other side so that I have one variable by itself. So that would be a negative 2x minus 1. Okay. So I know what y is now. I know y is a negative 2x minus 1. So that means I can take that and plug that into where the y is at into the other equation because y is that. Okay? So I'm going to have a 5 on the outside, and now the y is no longer there. It's now a negative 2x minus 1. Okay? And then you write the rest of the equation. Okay, so now when I'm solving this, because I replaced the y, I don't have 2 variables, I just have 1 variable that I'm now solving for x. Okay, so I need to distribute these guys in here and then combine my like terms. Okay, so I would have a negative 10x minus 5, and then now the negative 6x equals 7. Okay, so combining our like terms, I would have a negative 16x minus 5 equals 7. Add my 5, okay, over to the other side. So now I have a negative 16x equals 12. Okay, and then divide by a negative 16 on each side, divide by negative 16. So if I were to simplify that down, okay, 4 can go into both of those, but it would be a negative 3/4. Okay. So that is what my x is. So now I need to plug it back into one of my equations where there is an x, whichever one looks easiest to you. Okay, and again, you could change your 3/4 to 0.75 if that's helpful if you're plugging it into your calculator. Okay, but you just pick either the top equation or the second equation, which one looks easiest. And I usually just look at the x's and which number is the smallest, and that's the one I choose. It has to work in both equations, so it doesn't matter which one you're actually plugging it into. Okay, just pick the easiest route. Okay, so I am going to plug it into the top one. Okay. So I have 2x plus y equals -1. And I'm going to plug, because this x is that, I'm going to plug that into there. Okay? So I would go 2 times a -3/4 plus y equals -1. So now I can solve for the y. So if I multiply across, that's going to be a -6/4, right? This is a 1 plus y equals -1. Okay. I could move the 6/4 over and get common denominators and do that, or I can multiply, whatever's easiest for you. Okay, I'm going to multiply by 4 just because we've been practicing that. Okay, my 4's would cross cancel, right? And it would just leave a -6, but now I've got to distribute that to that. Okay, so that's going to be a positive 4y equals -4. Move my 6 over to the other side. Okay, so that means I'd be adding 6 over here. So now I have 4y equals 2. And if I divide by 4, right, to each side, divide by 4, divide by 4, my y would be 1/2. Okay, so my y is 1/2. Okay, so now I have my x and my y value, and then we're done. Okay, so if I were to kind of look back at my graph here, again, this was a sketch of that. My x was a -3/4, okay? So you would go this direction, right? And then my y was a positive 1/2, which is just barely up above, okay? Which, again, I did a sketch, it wasn't perfect. But it's in the right location. Okay, so that would be my 2 answers. All right, I gotta pause the video so I can erase and make space for our next one. Also, I don't know if you've been noticing that in my recording of my video, my mouse hasn't even getting stuck in the upper left-hand corner for my followers that have been watching my other videos. Super nice. Thank you, tech department, for fixing that. Okay, so try it 1B. Okay, again, you can sketch it. I'm going to sketch it at the end. So on this one, I am actually going to try to, just because we did substitution on the last one, we're going to do elimination on this one. And the only reason why I would choose elimination is because neither one of the equations has a variable by itself, okay? This one actually had a variable that was by itself with no number, so it made sense to do substitution with me. But this one, it doesn't. There's no variable that's by itself, okay? So I'm going to stick with the elimination, okay? On elimination, it does not matter, okay? It does not matter which one you're choosing to get rid of first, okay? Because you have to solve for both of them. We have to solve for the x and we have to solve for the y, okay? So I am actually choosing to get rid of the x's, okay? So I have a 3x and a 6x, and I need both of them to be the same number, okay? So I can get this one to be a 2 by multiplying it, or sorry, to get it to be a 6 by multiplying it by 2. Okay, but I can't just do it to part of it, I have to do it to the whole thing, okay? So we put parentheses around the whole thing, and I'm going to put a 2 on the outside. But remember, when we're doing elimination, besides them being the same number, they have to be opposite, right? Because in order to eliminate, you have to add and subtract from each other, okay? So that means I'm going to distribute a -2 to everything to rewrite this equation, okay? And then I'm just going to write it down below the other one, okay? So -2 times 3x is going to give me a -6x. And -2 times a +2 gives me a -4y. And then a -2 times 5 gives me a -10. Okay, so now I'm not looking at this guy anymore, I just rewrote it. Okay, so I can already eliminate, but there's a problem here, okay? Because when I eliminate, it gets rid of my x, which was my goal, to solve for y, but now I can't even solve for y because this was eliminated, okay? So what we're looking at is everything on that side became 0, and then what's left on the right side is a -7. Okay, is that ever true? Is 0 ever equal to a -7? And the answer is no. So actually, we have no solution to this one. Okay. And it's because, I'll show you the graph just a minute here. When we go to graph this, these lines don't ever cross each other. Okay. So if I were to solve these equations and get the y's by themselves, okay, so like the first one there, sorry, it's all marked over, you have it on your page. We had 3x plus 2y equals 5. If I solved that and got the y by itself, okay, and moved the 3x over to the other side, it would make it a -3x, and scooted my 5 over, and then divided everything by 2, okay, I can graph this equation, okay. Same thing with the next one, okay, so if I got the y by itself, and moved the 6x over, scooted my 3 over, and then divided everything by 4, okay, I can graph that one. But what's happening right now is if you look at these two slopes, okay, besides the first one actually being simplified and the second one not being simplified, those two slopes would be the same. So if two things have the exact same slope, it means that they never cross each other. They're both increasing, okay, going up and to the right, or down to the same. Well, this one's negative, making it a negative slope. If we were to graph those, this guy would look like this. Okay. We have one that's like going like this. If I were to graph it, the other one's going like this. Okay. They go through at different locations on the y-axis, but their slope is the same. So they never cross each other. Okay. So the answer to this is no solution because they don't cross. Okay. This one here where we did it, there actually was an intersection point. Okay, so we can get a solution. That one it doesn't. So it's no solution. Okay, moving on to the next one. So going on to example 2. Okay, so example 2, story problem, your guys' favorite. Okay, it says Malcolm earns money doing chores for neighbors. His goal is to earn at least $200 each week, but he can work a maximum of 20 hours per week. Malcolm must spend at least 5 hours per week walking his neighbor's dogs. For how many hours should Malcolm work at each job in order to meet his goals? Okay, so this is a system of linear equations. So linear inequalities. Okay, so that means that we have the greater than less than. So inequalities are these signs that are down here. Okay, so you can see it down there on that step 3. Okay, so step 1, it says to define the variables. Okay, so you can choose one of them to be x, one of them to be y, because they're two different situations. One of them is mowing, okay, and then the other one is walking the dog. The two situations are totally different. Okay. So then step 2, it says write inequalities to model the constraints. So constraints means how far up, how far down, like that's what the word constraints mean. Okay, you're going to see this word being used quite a bit. It should have been one of your vocab words, but really constraints just means you're going to have inequalities. Okay, all right. So it says Malcolm wants to earn at least $200 each week at $20 per hour mowing lawns and $10 per hour walking the dog. Okay, so they wrote the equation for you. This should be something that you already have. Okay, so $20 per hour. So one hour you get $20, right? 2 you get 40. Okay, and then the dog one was per hour. Okay, but we're not using x. Okay, we're using y because we're talking about the second situation. They mean the same thing. They're both per hour, but they're two different situations. Okay, so the combine of that. They want to know how many of those hours can they work to get at least to 20 or 200. Okay, so the at least is your inequality. Okay, that's your constraint. Okay, and then the next situation now is Malcolm cannot work more than 20 hours each week. Okay, so that means the combining of the mowing the lawn and walking the dog, the most he can work is 20 hours a week. So it's a totally different situation equation than the first one. Okay, then the next one down is Malcolm must spend at least 5 hours walking dogs each week. Okay, so then there's your constraint for that. Okay, so basically these are 3 different lines that you're graphing, and I already told you to graph. okay, have the graph ready for us, okay? So when we're doing graphing with inequalities, it means we're shading things, okay? So they graphed each one of the lines, but when we're looking at it, we're shading above and below. So if you remember when we did these, most times we just had 2 lines. Okay, don't write this, but like when we got graphs, and we would graph a line, and then we'd say, okay, well the y was bigger, so like whatever the equation was, that part was facing that, so we would shade up above, right? Remember that? And then we'd have another line, it was going like this, and then we graphed that line, but this time the y's were smaller, so the y's were smaller, we could go down, so we go like this. But what we were looking for was the common shaded area. Okay, this is the exact same thing. Okay, so you graph each one of them. Okay, so if you were to plug in 0, zeros, okay, they graphed it out to the right, which is the red one. Okay, the red one right here. And the part that's facing the y, so we're looking at the y, the part that's facing the y is bigger, okay? So that's why they have an arrow, because the bigger part would be going up above, okay? That's why there's an arrow here, okay? Because technically that keep on going up. Okay, then the next line was the blue line, okay? So my y here, the part that's facing it is smaller, so smaller means below, so that's why they have this guy right here, okay? So we're looking for the common area between the 3 of them, okay? And then the last one was just this one where y is bigger, okay? So this is this line right here. So when the y's are bigger, that's why they have this arrow going up. That would be above. So the common area, if you were to shade in 3 different colors, is the yellow spot, okay? So if you didn't shade that when you graphed it in your notes, this is the common spot for all 3, okay? So it says use arrows to show the region, which you didn't use arrows. I wanted you to use shading for 3 different colors of colored pencils or whatever you do, or the darkest shading area. They want to say at any point that's in that location, any point, okay, then that would be a solution to all 3 of those equations, okay? So the one that they're showing is 12, 7, okay? So if you were to go over 12, okay, so go over 12, so here's 12, and go up 7, well, 7's at this location right here, right? So if I met in this location right here, as long as it's in that yellow area, that's a solution to the equation, okay? So if Malcolm spends 12 hours mowing lawns and 7 hours walking the dog, then he would have met his goal, okay? That's not the only solution to it. It's other numbers that are in there, but that's one of them. Okay, so now we are going to try it. Okay, so turn to your try it number 2. Okay, so it says sketch the graph of the set of all points that solve the system of linear inequalities. Okay, so we're going to have a total of 4 things that we're looking at. Okay, so I'm going to draw a sketch. Okay, my first one, I'm going to get the y by itself. I'm going to rewrite it. Okay, so if I move the 2x to the side, my inequality is going to stay the same, but now it's negative 2x plus 14. Okay, so I'm going to do that one in red. Okay, so 14, if I were to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, it'd be right there. Okay, and then my slope would be down to over 1. Okay, and I'd keep on going down to over 1, okay? So I would be able to extend this line so it keeps on going. Okay, next one, if I get the y by itself, so let's do this one again. If I were to get y by, or actually, I'm going to plug in zeros on this one, okay? So I'm going to plug in a 0 for x, solve for the y, and plug in 0 for y, and solve for the x. Okay, so if I plug in 0 for my x and solve for my y, then that means my y would be 5, because I go 10 divided by 2. Okay, if I plug in 0 for y, that y is gone, and so it's just x is equal to 10. Okay, so I can plot those 2 points. So 0, 5, so I plot 1, 2, 3, 4, 5. Okay, and then 10, 0, so 10 being someplace like way over here. Okay, so then I could connect that guy. I haven't done any shading yet. I just want to get the graphs, the lines going, so I don't lose track of where I'm shading. Okay, so now I can actually shade because these next two, there's nothing really to graph. It's the X line and the Y line. Okay, we're just going to shade based off of that. Okay, so going back to the red one. Okay, so the red one, I'm looking at the part that's facing the Y is smaller. So the part that's facing the Y is smaller would be going down, right? So all of my shading would be going this way. Okay, would be going down below because my Y's are getting smaller to go down. Okay, then for the green one, if I got my Y by itself and move this over, divide by 2, my inequality is still going that direction. Nothing changed. It would only change if I had to divide by a -2. Okay, so my Y's on this one are actually getting small. Okay, so my Y's on this one are actually getting small. Just go right to this one. Okay, so far, our shaded is the red and the green. Okay, so now, and I'm just going to do blue for the rest of these. So we're going to look for the red and green and blue. Okay, so for my x's, if my x is 0, that would be right here, right? And it would be going, like the line would be the y-axis, basically. Okay, and they're saying that the x's are getting bigger. Okay, so if I were to draw my line, keep on going like this, okay, I don't want to overdo my graph, okay, that means that my x's would be getting bigger going this way. Okay, and I can keep on going up, okay, now for the y part, my y is at 0 is actually the x line, which is this guy, this one, okay, and they said that the y's are bigger, so the y's are bigger here, right? Okay, so if I'm constraining them within this, the area that is the darkest shaded with all of them is going to be this location right here. Okay, so that is my constraint. Below, to the right, and up above. Okay, moving on, and I believe this is actually our last one, and then we'll be done. It's actually a shorter section of notes. Yay for once. Okay, number 3. So this is the one that I wanted you to leave space. I don't like the example that's in the book, so we're going to do it the way that you should have learned in Algebra 1 if you ever got to it. And this is solving equations, but now we don't just have 2 variables, an x and a y. Now we actually have a z. Okay. So during the notes, I'm really wanting you to watch what I'm doing. And then I will pause and open it back up so that you can write the steps out nicer, okay? So for right now, you're just watching what I'm doing, okay? So it says, how can you solve a system of equations in 3 variables? So I had you write just the sentence and then these equations off to the side, because I'm going to go to a blank page, okay? And then you're supposed to write these guys right here, okay? All right, so in order to do this, we're thinking like we did before, okay, and we're starting to narrow down so we can get just 2 variables versus the 3rd variable, okay? So I'm going to a blank page right now. Nope, not that. Here we go. Okay, so, and again, I will come back and I will have a copy of this for you to write, okay? So our example 3, I'm just going to rewrite this, okay, was 2x plus y. I will give you a clean copy of this. Mine will be all over the board because I'm trying to fit it in, okay? So I just want you to watch. And we get a negative x plus 2y plus z equals 3. And then I have x plus 2y plus 3z equals 13. Okay, so my very first thing is to look at the variables that I have and see. So these are all constraints, right? Because each line has its own different rule to it, okay? So the top one, the second one, and the third one, they all have different constraints. Okay, so we are trying to pick 2 of the equations, okay? We're going to ignore 1. 2 of the equations where we see a variable that we can eliminate, okay? Yes, we could look at the second and the third one. We could do that. Okay, because the x's, if you look at the x's, we have the same number, one's positive, one's a negative. But I could also do the first one and the second one because we have the z's that are that way. Okay, so I'm actually going to start with the z's. Okay, so that means I'm looking at these 2 equations right there, just those. So if I were to ignore that third line, I could eliminate my z's, okay? So those z's would go away. These guys would go away. So now I just combine what I have. Okay, so if I drew a line, actually I'm going to rewrite it, it would be 2x plus y equals a negative 10. Okay, and then I have a negative x plus 2y because the z's went away, right, equals 3. Okay, so I'm going to go ahead and combine them just like they are. Okay, so this would give me x plus 3y equals negative 7. Okay, so now this guy is starting to look like the ones that we've done in Algebra 1. Okay, that's more manageable than the 3 letters. Okay, so now your goal is to go back to the one that we did not use, which is the third one. Okay, so this one right here, this guy right here, now I need to put him with one of the other ones, either the number 1 or number 2, okay, that we have to get rid of the z. Okay, so because we got rid of the z in this one, we have to get rid of the z in this one. Okay, so I chose to put it with this one right here. Okay, the only reason why I chose it is just because I have a positive and a negative. Okay, but I still don't have the same number. Okay, so that would mean that I would need to multiply this guy by a 3. Okay, and I'm going to write this off to the side so that you can see this. Okay, so this is x plus, this is that bottom one, the third equation, 2y plus 3z equals 13. Okay, and I rewrote the first equation by multiplying it by 3. So if I distribute it to all of these things, then I'm now going to have 6x plus 3y minus 3z equals negative 30. Okay, so I can eliminate just like I did in that very first one. Okay, so I have a 6x and a 1x, which is going to give me 7x. 3 plus 2y is going to give me 5y. My z's are gone. Okay, and then I subtract 30 and 13, and I get a negative 17. Okay, so now I'm going to take this equation, and I'm going to join it with this guy. Okay, so now I've got 7x plus 5y equals a negative 17. Okay, so now I'm just referring to these two equations. Okay, with those two equations, I need to eliminate something. So I'm either choosing, and again, there's no clear one on this one, to get rid of the x's or the y's, because both of them have different numbers and neither one have positives and negatives. Okay, so I am going to choose, I'm going to go different color here. I'm going to leave the red one alone, and I'm going to rewrite this guy. Okay. And what I'm going to do is I'm going to multiply it by a negative 7 so that I can eliminate the x's. Okay? So I'm going to put parentheses around this, and I'm going to multiply by a negative 7, and then I'm going to write it down below the red one. Okay? So a negative 7 times x is a negative 7x. A negative 7 times 3y is going to be a negative 21y. And then a negative times a negative would be a positive 49. Okay, so I just rewrote this guy. So now I can eliminate. I eliminated the x's, okay? Combining my y's just like they are, so I have a negative 21 and a positive 5 gives me a negative 16y. And then I'm subtracting 17 from 49, which gives me 32. Okay, divide by a negative 16, divided by a negative 16. Okay, so my y, very first answer, is a negative 2. Okay. All right, I have one of my answers. Now I need to solve for the other two. Okay, so you're going to plug into one of the other recent ones, not all the way back at the beginning with the blue, okay? One of my recent ones, and I'm going to plug in where there's a y at, okay? Because we just solved for y. So what you're looking at is the ones that just have the x and y, not the z, okay? And look for the easiest one for you to plug into, okay? And again, it doesn't matter. It has to work in all of them. So let's see. I chose the x plus 3y equals negative 7. That's the one I chose to plug into. Okay. So I'm plugging into, I'm just going to write it right here. So I'm plugging the y into where the 3 is at. So it's going to be 1x plus 3. And now I'm plugging in my y answer, which is negative 2 equals negative 7. So now I can solve for the x. Okay? So now I have x gives me a -6, but when I move it over to this side, it's going to be +6. So that means my x is a -1. Okay, now I have 2 of my answers. Okay, so once you have 2 of your answers, you're going to go back to the very beginning equations and pick which one, because it has to work in all 3. Pick one of them that you're going to plug the x and the y in to solve for z. So the one that I chose, so let's go back to, actually I don't use green, I'll use green. Okay, I chose to use this one right here. Is the one that I plugged into. Okay, so it was a negative in the equation and I'm plugging in a negative, so that means it's going to change it to a +1. Okay, and then I'm going 2 times my y. Well, my y is a -2, so 2 times a -2 would make it a -4. Okay, and then I have plus z, because that's what I'm solving for, is the z equals 3. Okay, so solving it down, 1 minus 4 would give you a -3. When I add 3 to the other side, that would mean my z is equal to 6. Okay, and then we are done. Okay, I'm fine with you leaving your answers like that. Usually the way that it's written, again, I won't be picky about that, but if you get to the Math Excel, that's the way they'll have it. They'll write it in order, okay? So you'll have a -1, a -2, because it's your x, y, z, okay, and then 6. Kind of like ordered pairs. You write x first and then y second, okay? So vocab word, again, they didn't have it listed, but they use it often just so you know what this means, is they say that this is feasible answers to the constraints, okay? Which means that if I were to plug all 3 of those in, it's going to work to all of the equations, okay? But they use the word feasible, so just in case when you come across that, these are the answers to it. Okay, so the 3B one that you had in your notes is the same thing, but it won't take as long as this one, okay? So the B part of your notes, which was back here, was a new set of equations, okay? So I'm just going to write them out, and that's why I said it only needed a half of a page, because this is going to be super quick. So this is the B part of your notes, 3B, not the triad, okay, the actual part of your notes, okay? So your equations, which you should already have, this right down, okay? And again, I'm just wanting you to watch. I will upload a copy of my notes nice and neat, or actual description of what you're doing as I do this video. So you can either copy it down in your notes, or if you have a printer and you want to print it off. Okay. If you don't need this part of the notes, then you don't need this part of the notes. Okay. Equals 0. Okay. So looking at looking for something that looks the same that you can go ahead and eliminate is what we're looking for. It doesn't matter if it's X, Y, or Z. I chose Z with the 3A problem. Okay, so if we look at these first 2, okay, is there anything that you notice that we can eliminate? Okay, and yes, we can eliminate the Y's. Okay, so if I were to eliminate the Y's, this would give me 3X, right? And then I would have, the Y's are gone, and then I would have 2Z equals 8. Okay, so we have our first one done. Okay, so then the next step was to go to the one we did not use, which is the third one. And because I got rid of the Y's, I have to choose one of the first or the second equation to get rid of the Y's. Which to me, this one stands out just like the last one. Because you already have a positive negative. I don't have to worry about distributing negative, okay? But I would need to multiply this top one by 2 in order for that to be a -2y, okay? So when I distribute this to all of them, I would have 4x minus 2y plus 2z equals 6. Okay, and then I'm just rewriting this one. So it's a -4x plus 2y minus 2z, oops, there's no blank about, just 2z equals 0. Okay, this is why this one was only half a page. What do you notice? and the z's went away. Oh, didn't do that. Okay, so then this would be 0 equals, and then the only thing that was left was the 6 and the 0, so that would be 6. Okay, again, this does not work out. This is never true. Okay, so again, no solution. Sometimes, and you might see it if it's like a drop down in the Excel, they'll use the word inconsistent. Okay. These two things be the same. So inconsistent or no solution. Okay, so we can't go any further. I can't write an equation with an x and a z when the x's and the z's went away. So you cannot solve it. Before, when we had the equations with just two variables, we were able to like graph it and know if they crossed, they had one solution, right? And then when they were parallel, they had no solution. This one we can't graph. Well, we could graph, but it would be a 3D graph, okay? Because it's not just two, it's not a 2D, it's not an x and a y, it's a 3D, okay? So it'd be hard to visualize where that line is at, okay? So it's an inconsistent system. It's a no solution. Okay, so as homework, you guys are going to try it number 3 and 3A and 3B in your notes. If we get time, we'll grade it in class. If not, we will check it tomorrow at the beginning of class to see how you did. Okay? So 3A, do it on your own. 3B in your workbook. Okay? See you tomorrow. Okay, so I decided to record just for those that are at home. So after you've done it, on the first one you should have got these 3 answers. So if you didn't, come see me so we could see. I have the steps out that I will do in class with them. But you should get an X, Y, and a Z on 3A. When you do 3B, you'll get your first equation, and then just like the last one that we just did, where you had 0 equals 6, that is never true. So that's why they say there's no solution. That is never true. Okay? But if you solve it and you get to that second step and you get 0 equals 0, that actually is true. Okay? I had you graph on one of your vocab ones. I think it was the 3rd graph, I believe. Your graphs were the same line. Okay, so when you have parallel lines and they never cross, that's your no solution or your inconsistent. Okay, 2 of these equations are going to have the same answer, so that means they're the same line. Okay, so 0 equals 0. If we were to actually have the 3D graph, they would all wind up being on the same line. Okay, and so the way they say this one is it's an infinite amount of solutions because they're all on the same line. Okay, so everything that is on, like, say I were to graph this 2 lines and I were to graph something on a graph that looked like this, and then I went to graph the next line and it was the exact same line, okay? And then I went to go graph the 3rd line, it was the exact same line. And then that means that whatever I plug in that's on that line is going to work in all 3 of those graphs. Okay? So that's what they're trying to say on 3B. Okay? So if you did it, you got 0 equals 0, just make sure you write infinite solutions because that's what you're going to see on the map itself. Okay, good job, guys.